right. Okay, all right. Thank you so much. Hello, everyone, and good afternoon. I don't know where you are actually, but here it's 5 p.m. Kigali time. So welcome to the React JS Rwanda online meetup. We are so excited to have you with us today. Wherever you are in Rwanda or elsewhere around Africa or around the world, I'm Didas Mbarushimana, part of the team of React JS Rwanda, and I'm the organizer. All right. So, and lead of React JS Rwanda. Anyway, I'm really happy to have you to kick off this online session. React JS Rwanda is a growing tech community all about learning, sharing, and connecting developers, software developers around Africa and beyond. Beyond. All right. So we are glad to have you here today. Here is what you will expect on this 3 hours. First of all, we'll have 4 speakers. Each will lasting up on 30 minutes around. After that, the first 2 talks will have a short break, and after the break, we'll close the evening. We'll close this session with question and answer. So feel free to put your question in the chat. Yes. So after that, we'll finish with thank you. And let us not spend a lot of time and start to welcome our first speaker. He's called Josue, who will talk about AI, so how accelerating React JS development with AI. Thank you so much. Welcome, Josue, and we are so excited to have you this evening. So you're welcome. Thank you. And yes.
Yeah, all right. Hi, everyone. Hi, everybody. We start with the demo that will help us to.
Sorry, I think he'll be joining back.
Sorry, we start with the demo. I'll share my screen for sure. Yeah, I hope everyone is seeing my screen. My talk is all about how we can accelerate the React development with AI. I'll start with myself. My name is Josue Nyukuri. I'm based in Kigali, Rwanda, and um, I have a couple of years experience. Basically, my whole life experience. I've been using React, and yeah, I thought that this would be a good thing to move forward to talk about how can you can use AI with the React Native development, uh, and yeah, this is the era of for artificial intelligence, right? If you don't use artificial intelligence in your work, soon or later you will be left out of the work. We have to accelerate whatever we are doing. No matter how you do, we have to use React. You have to use AI in order to have a great result and in order to have the have a product in faster way, and also in in very uh, intelligent way. We have to use React, uh, React, React JS, React Native, with all the tools that are available in order to move forward. So on the topic about the era, we're going to talk about the era that was in the past. There was like in 1990s to 2000. Uh, there was like a period that marked about the development of the dot-com bubble. That was the era, and now when you move 2000 to 2010, that's where Web 2 came, and uh, we start showing and getting the experience that a user should can interact with the web. And here on, we are moving into the era of the smart web, where we have to use the AI in order to increase the productivity and also to increase the user experience of the user, right? Uh, we cannot You cannot rely on whatever you are writing, because if you are in this era, if you are writing codes and you want like to write it in other way, that means you will not deliver faster, and it's probably sometimes there are another person that is on site and working on the same problem. That means you miss the opportunity. So we have to use the tools that are available in order to have uh, what we want to deliver to the community, right? Uh, and then we have a couple of tools to use. If we can take a look into all the tools that we have in the world right now, we have so many, and you have to use those tools to get a better result, and also to have a product that meets the standards uh, of technology that are out there, right? In the tools that we have Copilot. Copilot, I think everybody knows Copilot in nowadays. Uh, Basically, when you are writing codes in VS Code, it just suggests you all the probability that you can use the codes. Let's say if you are building an app that takes that can take you a week to complete, you can complete it in a day, right? And basically, Copilot goes in the direction um, for for developing backends, right? That's where it will come very handy, right? And we have V0. Basically, V0 is a web application that we can use to get an application. Why I say that we can use V0, especially when it comes with React, is when you have, let's say you have design, right? You have design, you want like to have something quick, let's say the MVP, and you want to go out the market, or you wanted to test the product if it works. Usually it can, in the old days, it can take you like even 2 months or three, right? But now you can build the thing that you should have built in 2 months. You can do it in 1 week or something like that. So basically, everybody that worked on front end, I worked on front end. I know how building a good interface, reactable interface, the interface that React uh, according to the standards, it's very complicated, right? You cannot wake up in the morning and expect that you have the thing that is working, right? You have to test everything. But in this time, you can just use the tools available, like Visual and all of that stuff that are available, and then you can have a design ready. Be in mind, be sure that you are passing the right commands to the AI that you are using in order to have the good result. If you don't pass it the right commands and explain what you want, especially when you have a design, that helps the AI to understand what's going on. And then you can have a UI that you should took you like one day developing and hands-on developing that feature. You can have it in just 5 minutes, and that's a win not only for developer but also for the company as well. And then we have CRUD. CRUD helps to build the user interface as well with React and many frameworks. But it will help you more understand what's going on instead of like wasting your time going into the code, figuring out what's going on and what's not working. And yeah, you have to use those tools available to debug faster and have the good results as we are in this era of artificial intelligence. And there are so many tools available out there, and you have to use these tools uh, to have something good. We're gonna try to build something. We're gonna try to build, let's say, an attendance table, an attendance app that, let's say, a person if comes, he wants like he needs to check in. Like you need to know like this person came let's say around 10 p.m. and then he goes out around 2 p.m. So 2 a.m. Sorry. You have to know something. You have to know that this person checked in this time and then goes out this time. So that's what we're gonna build. I'm gonna try to hope you are seeing my screen. I'm gonna go to V0 basically and try to prompt in the I hope you're seeing my tab right now. So we're gonna try to build that thing. So I have a prompt here that I said, okay, I want an attendance table that display the rows as follows and have columns that are structured. Uh, I'm trying to correct my prompt and therefore the AI to understand what I want. And columns for employee with employee name. Let me try to with employee name, and then we have the columns for the days and weeks from Monday to Sunday. And then for each day, we have two fields: check-in time, and this can be in hours, and also in minutes. Check out as well to be with hours and minutes, and that is that is how the columns are structured, and for each employee. So usually to design something like this, let's try to run this first, then we will see what it gives us. Basically, it's going through the prompt and trying to get not give the design to the AI right now. So it will figure out and then know at least which design to present to me, right? And usually this design implementing this will take you like hours, right? For the person that works on the front end knows what I'm talking about. You cannot like have the thing that's complex like this in just like two minutes, 2 minutes or three. So basically, you see that we have the design that is ready, and we have the check-in time, we have the checkout time, and I want this design for a person to be able to enter the time. Let's try something like that. I want to tell the AI, I want a user to be able to set a time save it locally. Yeah, basically, we have like to try to tell the AI what the AI will take it as reference. Let's say like basically I want when a user clicks on the row that do not have time, open a dialog where he can pick an hour and minute, and then save, and then that will be saved locally, and also make sure it is being displayed accordingly. So let's try this one and then see how it will react and implement this functionality for us. Yeah, this is the time where we have to use the tools available for us to deliver quicker and go to the market and try something that we can have, right? Otherwise, we have delays in delivering our product and all of that stuff. Yeah, basically what it's doing, it's going through, and also you have to make sure, you have to understand that it is going in the it is going in the codes, because we have the codes here. I think I can make this a bit bigger. Yeah. Okay. So yeah, basically we have the codes here. This is the code that this wrote, and yeah, we have static data. That this means when you want to use this component, you just have to take this state and replace it with your own data, and then the thing will work as expected. So let's try and see what the AI gave us. Let's try 1 p.m. and yeah, saved. So you can see that we have the UI that is very interactive, and also the UI is good, right? You cannot have this thing in just 10 minutes or so, or 5 minutes. I think we have this in 5 minutes. Otherwise, you have to work all day, whole day, even night, even night, without accomplishing the result that you wanted. So yeah, this you can write, select the time that you for checking, and also you can write the time for checkout. Yeah, and it will be there. So basically, you can try something new. Let's try like to tell I want a user to be able to download the SSB file of the data. So let's see. This is right. This is coming in my mind, right? I don't know what it will give us, but I'm hoping for the best. Definitely. So it's going to the codes. It try to see what it's doing. If you look here, it is writing the code in real time, right? And you can see it here. So even though he already, even though the AI wrote the codes before, but when I try to run something, it goes into the codes and understand what to put there. So yeah, you see we have here the app, and yeah, boom, I have the file that is installed. So yeah, it's opened up in the VS Code, but you see that we have a file that can be uh, used as a sheet, right? As Excel sheet. So Yeah, I think this is the time where we have to use these tools to in order to have the product the product that we want to give to the community, and also have something that is great. So, and after that, you can even clone this project, or even download a zip folder, right? And then in that zip folder, I can bring this here. You can see that we have uh, yeah, we have the app, which is Next.js app, and we can try to open it and try and see, because we still have some few minutes. Yeah, yeah. Let's try to open it and see what we have here. Oh, this goodness, I opened to one. Yeah, so let's try that. Yeah, I don't know what's going on. Yeah, but yeah, the idea is that so you can use these tools to move faster, and also to have something that is working for you to go to the market, right? Let's say if you want like something that is at least to prove the concept that this thing can work. Yeah, have use AI. Everybody has to use these tools that are available in order to help to help the organization move faster and also deliver faster. So I think that's what I can say about AI. Basically, you can say much. You can say you can say from the morning to the evening, depending on what you have in mind. But basically, we have the tools that are available. That was my main point for people that is also that is still using analog ways to develop the thing. I think we should stop. Otherwise, you will be repressed, right? For the person that you will not be repressed, it is the person that using these tools to help the organization move faster, right, and deliver the features that he wants to their end users. Uh, um, Thank you. I'll hand over my time, or if there is anyone that has question, you can ask. Yeah, thank you. Anyone that has question, please. Yeah. If there is no one that has question or anything to say, yeah, I'll hand the time to Assunta so we can continue with others, and I'm very excited to see what others can offer, and I hope this day will be great. Yeah, Assunta, you can take on.
Thank you very much, Josue, for the representation. I think, yeah, questions will come
Okay.
maybe later. Can continue with the next speaker.
Hello, am I audible?
Yes.
Okay. I hope my screen is visible. Yeah, so I'll start by introducing myself. My name is Eugene Odhiambo. I'm a software engineer with about 6 years of experience. And yeah, I've worked with a couple of organizations, both established companies and startups. And I'd say I'm passionate about building high performance, secure applications while also creating delightful user experiences. Yeah, so like many of you, I've faced the daily challenges of getting the right data at the right time for our front-end applications. Could be mobile, could be React, but today I'll just be focusing on React apps. So as developers, in our day-to-day, we are also end users. So personally, I think over the years, user expectations have really risen. And for me, a slow application is always like a no-no. And our jobs as front-end devs and React devs is to render beautiful UIs quickly. But then the best UI is useless without the data it needs. Because say, for instance, if you are looking for maybe a specific car, you search, the list populates, but then when you click on it, you also have to wait a couple of seconds for the vehicle details to show up. You'll probably move out of the site and then probably find an alternative website to find what you're looking for. Yeah, so as engineers, user experience is a very important thing. And then since it impacts user engagement, which directly impacts conversions and even SEO rankings. And these are very important things for organizations out there. Yeah, so focusing on React, I think the greatest challenge we face in our day-to-day work is you find that the backend is already there, and as a front-end dev, you don't have control over it. And if you're lucky enough, and it's mostly REST, to be honest, it's widely used. I know many of us are familiar with GraphQL. If you're lucky enough, you'll find your backend team had already implemented GraphQL, but that's rarely the case. So mostly you'll always find is REST. So today I'm going to focus on how you can leverage GraphQL on the front end. If the backend is already using GraphQL, then well and good. But if your backend is using REST, we are going to look at how you can leverage the benefits of modern data fetching without a massive backend overhaul. So without like really relying on your backend to go ahead and implement GraphQL for you. And so what I'm going to talk about today is basically exploring how you can take control of your data fetching, enhance security in the process, and supercharge your React apps with GraphQL, even if your backend doesn't speak REST APIs. Hence, the headline for my topic today, as you can see on your screen, is efficient data fetching and security in modern React apps with GraphQL. Yeah, so my agenda for today is as follows. We'll first go through the challenges we go through while using REST APIs or the traditional ways of data fetching as devs, and then we'll look at how the solutions around it, around the solutions for addressing these issues using React and GraphQL. Maybe show you a few code examples here and there. There's a project that I think I'll share a link, or you can just look it up in my GitHub, and then yeah, we'll wrap up with best practices, key takeaways, and then if you guys have any questions, I'll be glad to answer them. Yeah, so let's start by looking at the issues that we have with the REST APIs, to be more specific. So the first issue, definitely, as you all know, is so REST APIs are powerful and definitely widely used. But if you have a complex front-end application, you'll realize that as it becomes more dynamic and component-driven, we often hit some familiar walls trying to make a couple of API calls here and there, managing your endpoints, blah, blah, blah. And especially if you have like so many components in a single page, trying to access different kinds of data and each making like different API calls. So or at the top of the list of the challenges you face is normally overfetching. Say for instance, you're on the home page, and probably on the home page, you need to display the user's name. You had hit a login endpoint before, but all it gave you was just a token, a refresh token, and a few details. The response from the login endpoint didn't have the username. So you have to hit another endpoint, which is probably the profile endpoint, to get the entire user's profile. But then the response you get from the backend has like 50 fields. So you just fetched 49 fields, which you don't need. So this is pure waste of bandwidth, processing, and memory on the client. And maybe to visualize this, imagine a huge JSON response, and you are only highlighting a tiny bit, like a single line, and that is what you actually use. So that is what we mean by overfitting. With GraphQL, you can have like a single path, and the good thing with it, you just specify exactly what you want. If it's the username, say the first, last, and last name you want, you specify that, make your API call, and that is exactly what you get. So it solves the overfetching bit. Similar to overfetching, we also have underfetching. So let's say you are working on a dashboard, and your dashboard is showing users their latest orders, the products in those orders. So you often end up in what we call a waterfall of requests. When you have different endpoints for these things, you have to fetch the users, then loop through each single user as you fetch for their orders. Then again, you have like an n times n number of orders, which then you loop through trying to fetch products for each order. And each trip definitely made to the server always introduces latency. So this sequential fetching kind of kills performance and makes the UI feel sluggish over time. And when I started the talk, remember I said that user experience is like almost everything. I try to think of front-end devs as artists. So as an artist, you strive to keep your audience or the consumers of whatever you are trying to showcase as glued as possible, because otherwise you won't convert your prospects into actual clients if that's a thing in your organization. Yeah, so underfetching is a huge issue, and with GraphQL, you get to kind of combine and get everything you want. Exactly, you can go specify exactly what you want, fetch them all at once, and then display them on the UI, as I'll show you later on. And then the other thing I'm going to talk about is API sprawl and versioning. So one of the challenges I know we face is when the backend introduces a new version to an endpoint. So let's say you have an API stroke v1 stroke users, and then they introduce another version, API stroke v2 stroke users. I can maybe use the previous analogy that I gave you with the users and the orders and the products. So users, you could be using v1, products, you could be using v2, and then orders have a v3. So kind of trying to keep track of these versions, the backend have to keep track of these versions, and then the front end also keeping these versions on the front end, keeping track of these versions on the front end as well becomes kind of a nightmare, because front end changes often require specific backend API versions. So knowing on this page you're supposed to be using v1 of this endpoint, and on another page you're supposed to be using v4 on the same endpoint. So yeah, makes it a bit tricky. And then we also have complex client-side state management while working with the traditional REST API. So you have to kind of use some of those third-party state management. It gets to a point that even context API becomes a bit insufficient. You have to kind of implement other state management techniques like RTK, that is a Redux toolkit, which, to be honest, always have some kind of a learning curve to it. So yeah, you realize that managing loading states, errors, manual caching, and ensuring there's data consistency across components after multiple REST API calls can lead to significant boilerplate code, and the more code you write, the more your app is susceptible to bugs. And yeah, just think about tracking pending, fulfilled, and rejected states for every API call you make. It becomes a little bit tiresome. And then we are humans; we often make errors. So if I've in the past tried, before I started using GraphQL, I've in the past tried to reuse the same state for tracking the state of API calls. So you'll find that maybe on the homepage I was using the same state to fetch users, and then when I get the first couple of users on the next page, I'm fetching maybe two things related to a single user. One is done loading, the other one is loading. The UI will always show loading. So those are some of the things that GraphQL aims to solve. And then just overall performance degradation, yeah, because all these factors combined, they create a slow, frustrating experience for our users. And it's always a bare minimum or like a standard to always build with your users in mind. So yeah, I think that mostly covers the challenges we face trying to make our users happy at the end of the day while using REST APIs or what we normally what is widely used across. So yeah, so today we're going to look at how you can take control and solve some of these issues or challenges that come with the traditional way of. I know there are other ways you can optimize your API calls, but imagine, because I'm sure most of you have been in a situation where you just joined a company or a project, the backend is done, and probably the engineers that did the backend are no longer there. They throw a documentation at you, couple of endpoints, so much stuff, and you're supposed to be integrating them to a new or an existing front end. So what happens then? And you still want to benefit from GraphQL. If the backend could migrate to GraphQL, then well and good. But if they can't, doesn't mean that it's basically the end of the road for you, and you have to conform to what's already there. So I wouldn't like to assume that everyone is familiar with GraphQL. So maybe I can just give a brief description of what GraphQL is. So GraphQL is not a database. It's not a framework. It's just a query language for your API and runtime for getting for communicating with the servers, just like REST API does, but in my opinion, in a more efficient way. So the principle of GraphQL is basically you get to ask for exactly what you need and nothing more, nothing less. And that is exactly what you get. No more, no less. So this fundamentally solves the overfetching and overfetching thing. So this basically shifts the power from the backend to the front end, since now you define exactly the data shape you require for your use case, regardless of what is on the server side. So since you don't have control over the backend, I'm going to address the backend is REST dilemma. So this can be solved through a front-end gateway. And the good thing is React has evolved over time, and you'll rarely find teams or companies just using vanilla React. Because of things like SSR, you'll find you'd be using Next.js. Personally, I've used Remix. So since these frameworks have like a server side of things, it makes it very easy for you to come up with like a proxy or a gateway where instead of your front end communicating with the backend directly, you can have your front end communicate with their own server, which then communicates with the backend. So think of it this way. You need to make API call because assuming your server, your Next.js server is deployed in the same network as the backend service, because that is how it mostly works. It works in most organizations. So it's easier and faster for your front-end server, which is in the same network with the backend server, to exchange data than the client or the browser from wherever the user is to communicate with the backend multiple times. So if you have like a waterfall kind of thing, and as I said, you don't have control over the backend. So for a single user, you have to fetch the list of users, then you have to fetch the orders, then you have to fetch the products under each order. You can have your server make all these API calls, then aggregate all this data into exactly what you want and present them to your front end. So makes it very easy for you and direct. That's one option. Another option is maybe, okay, if you have an existing React app, you can migrate it to Next. If you can't, and I think it's a standard for other companies, including where I work at, you are required to deploy the backend service the proxy service differently from the front end service. So they have to like be in different servers to. There are normally a lot of reasons behind it. You can just spin up a small Node.js server and do like a small implementation. It's basically the same thing, just that now it's not a single code base anymore. And I think I've done it a couple of times before. Once you do it the first time, second time, it normally clicks very fast. So yeah, I think I'll show you that in the next slides. But then that will be mostly just examples of how that will look like, because I see also I'd be running out of time. So yes, I think the implementation options you have like the two examples I mentioned, a standalone proxy and an Next.js API routes or Remix to Castro. Then I can talk about the advantages. So the advantages for this is you have enhanced security from the front-end gateway, because it's the middleware isn't just about data shaping. It's also a powerful security layer and control layer that you, the front-end dev, can influence. Because now you can have like centralized authentication and authorization instead of scattering authentication checks across multiple front-end components or different REST endpoints. You can centralize complex authorization logic within the GraphQL middleware. For example, if a user, you can this user access this field for this specific resource, that can be validated in the proxy before even hitting your backend. So all those complex checks and stuff can be done on the backend or on the proxy instead of the client side. You can do data masking or field level permissions. You can easily mask sensitive data or enforce field level permissions before the data ever reaches the front end. Because yeah, you can mask in as much as you can mask things on the UI. Remember, when you make API calls, it's done over the network, and people with malicious intentions normally know how to view that network traffic. So if you're masking a phone number or an ID number on the UI, someone can easily inspect and get the actual value of whatever you're masking. So another thing you can, if maybe your backend is not sufficient enough in terms of implementing rate limiting, you can do that at your GraphQL endpoint to protect both the middleware and the underlying REST service from abuse. Definitely, that will be prevention from DDoS attacks. Yeah, so I think you'll generally have reduced attack surfaces, a reduced attack surface as well, because now instead of exposing many distinct REST endpoints, you'll be exposing a single well-validated GraphQL endpoint, which can be easier to secure and monitor. So yeah, there are so many advantages to it. Because of time, you'll have to kind of go do your own research, because with the internet, these things are everywhere. Then there is the API aggregation. Can consolidate data from multiple microservices if you have a microservices architecture in your team. And have them all into one unified client-friendly GraphQL API. And if you're working with a team of other front-end devs, it even becomes more easier because now if you establish this, it will be easier for other junior devs in your team to just focus on the other stuff. They don't have to figure out how to make API calls, how to define endpoints. You can make sure the process is well aligned with your front end goals, and then everything just becomes more of a plug and play. Yeah, and these results to a more improved or an improved developer experience, especially if you're working as a team. And yeah, crucially, all the powerful client-side features remain. Query, there is the intelligent client-side caching with normalization of consistent updates, efficient pagination, and optimistic UI updates. And you find that most of these things, I kind of try to refer to GraphQL as a solution that comes with almost all the batteries you need, because it handles like the caching. You don't have to worry about most of those things. So yeah, I think that I can go to the next slide. So typically, I don't know if the font is visible from your end, but this is just an example of how you'd go about implementing REST. So on the left is how it would look like for a simple, let me go back. For a simple Node.js service that's using Express, you define your two endpoints and then expose them via a port. And then on the front end, if you're trying to fetch books and authors, you'll have to, on the front end, you'll first have to get the books and then get the authors. Then while you list them, you'll list the books and then list the authors. So with GraphQL, what you definitely do on the backend is define a type def, and it will have a type of book and a type of author and a type of query that will have books and authors. So that is what now the front end dev will specify when they're fetching, when they're making an API call to your backend. Because on the right side, you'll see that we are specifying that in our query, we want to get books. And for each book, we just want the ID and the title. If it's only IDs that, because a book could have so many fields, number of pages, a lot of stuff, some of them that we typically won't need. So with this, you only get to specify exactly what you want and then make the API call once. And as you can see, GraphQL has the use query function, which comes with a lot of stuff. It will show you when it's making the API call, it has a loading state, it has a header state, and the data that you get after the API call is made. So all you have to do is to maybe just destructure the data that you got, and the rest of the part of the code just looks the same for rendering the books and the authors. So yeah. Then I'll take you to the best practices. So since you'll find that you're trying to get control of your data, you'll mostly have to implement this proxy and the GraphQL bit yourself. So some of the best practices is to make sure you have a client centric GraphQL schema. You structure your data in a very friendly way. You optimize your resolvers. I mean, it's a really broad topic that if I go into details right now, I'll definitely run out of time, and I see I'm already out of time. Make sure you focus on security, have robust error handling, leverage client library features, because the Apollo client comes with a lot of things, and I kind of feel like most times devs don't utilize all of them. And then there's component collocation of data needs. Yeah, so for the takeaways, there's the front-end empowerment. You, the React developer, can build your a custom GraphQL layer. I know it gives backend vibes, but then as you become more mature in your craft, you'll realize that as a software engineer, you can't just be limited to scaffolding UIs and stuff. You have to kind of be more pragmatic and explore other things as well, and kind of know, in as much as you work on front end, you need to know how things work behind the scenes. So yeah, you can build your own custom GraphQL layer to optimize data fetching and enhance security. And since GraphQL also solves component co-pain points, and it eliminates over fetching, underfetching, and simplifies complex data needs. There's the security in the middle that comes with the proxy, and then yeah, performance always wins. So I think that will be it. I think I also have some Kanban board project I did. It's a public project on my repo. You can just go to Eugene Dev, and then you'll find a Kanban board repo over there. I did a very nice implementation that you can go check. It's an Next.js app that uses a router, and in the root layout, you'll find how I structured it. We have the providers, and I kind of separated that to another component. Which is the providers.tsx. And just basically, I added some documentation to guide anyone who is curious about having a similar implementation. So for the backend, it was just a small demo, but yeah, for the middleware, you can just point it to your backend and convert the data you get back as GraphQL. Yeah, so for some cases, this might be like an overkill, and it's good to know when to apply this approach and when not to apply. So mostly you will want to apply this approach when you need superior front-end data fetching capabilities, but have an existing REST backend, or when you're dealing with multiple microservices and you want a single unified API for your front end, or when you want to rapidly iterate on front-end features without constant backend changes, or when you want to enhance front-end security and control priority. I'm sure anyone who's worked in the financial sector or healthcare would agree. And then, yeah, I think that will be the end of it for me. And yeah, I also have a slogan, and it says I aim to spend more time working on system rather than in systems. I think that's self-explanatory. And yeah, that brings me to the end of my talk today. So I'd like to give the session back to Assumpta. Assumpta, are you there?
All right, all right. Thank you so much, Eugene. So, all right, everyone. We are going to take a short break, 5 minutes around, so to catch up and to stretch a little bit. All right. So before we continue, I just want to say thank you so much for all of you for being here with us today again. It's a really great to see how our React community is growing and showing up. Yes. So if you haven't already be in the community, so we have React JS Rwanda on Discord, on LinkedIn, on WhatsApp. On Discord, people are so movement, and WhatsApp also. So we still have two amazing speakers so that are coming up. Don't go far, and we'll be back shortly. Thank you so much.
Hello. So as we wait for our next speaker, maybe to join, keep waiting. There's a lot of things we still have for you.
Hi guys, good evening where you are. My name is Ian Rioba. Today I'll be taking you through why some applications are very fast or feel very fast. I know like while interacting with many different applications, whether it's on the mobile phone or on the web. There's usually like a category of applications which feel like they are so fast, it's like they're just right in front of you. So a term we usually use in such an experience is native. Native meaning the sense that it is just besides you, or something that feels like it's just literally there. So native applications that feel very fast, they usually, the formula in making them very fast or feel very fast, it's not that difficult, or it's not like some magic wand they use somewhere to just make them that fast. They usually take a different approach from everyone else, or for a different approach on top of the things other people already have implemented. So the first approach they usually do is they bring the data closer to the user, and they make the process of data fetching from like the user's device to wherever that server is. They make that round trip shorter, and that term usually is what we define as latency. So as much as we might have like very fast internet speeds, there are some limitations in just me being connected to my internet right now in my computer, and that round trip for that communication to be done from my computer, you can imagine the sea cables all the way to some server somewhere in the US or in Europe. There's that latency, and no matter how we push the boundaries of internet speeds, there are some things we won't really. It's physics. That distance, 6,000, 10,000 kilometers, that data has to go. It will always hit like a certain threshold, or there's a boundary somewhere that it can't go past. So today's session is more about that, and making the conversation more about the user, day-to-day interactions with your applications, and some of the approaches we can take, which, by the way, these approaches were there even before the internet, but now when the internet came, we built like new technology, and we were like, oh, let's just focus on the servers, everything like that, and we spinned off to a direction whereby like the user's data doesn't belong to them anymore. It now belongs to the organization, like Google. Now they have your data, they keep your data, and it's yours. Imagine, instead of having it somewhere close to you, or even in your devices, and having them closer to the user just means it will be very fast. The user experience will be much better. So let me start off with some presentation here. So today we'll be talking about local fast and offline approaches. So you can just say like, how do we make things fast? In terms of fast, you could say, if you could put a number to it, you could say it's 10 milliseconds, or 10 milliseconds, which is like 1,000. Oh, okay, that's like a 100th of a second. So in terms of human speed, we can only see things maybe 20 times more than that. So it's usually around 200 milliseconds. But applications that we usually interact with day to day, they usually fall within the human speed perception, around 200 milliseconds. So by using like local fast approaches, we can even go beyond. We can go beyond like 10 milliseconds, which is super fast. Even your eyes can't see it. It's only computers that can perceive such a speed, and that can be can be attained through like a different approach from the client server approach. Yeah. So a bit of background about me. I'm a software engineer. Some of the things that I really enjoy doing is just trying out new technology. Like I believe like everyone needs to have a voice like on the internet or in the world somewhere. Like the internet is like a place whereby like you can have like your own little corner of the things you do, and you can make the world or people who share the same interest as you can interact with you, can get to know you in a familiar fashion, or even beyond that. It's a way we can interact. Some of my hobbies include running. I also love to cook and adventure once in a while. Yeah. So the things I've been learning maybe in the past few months have mostly been in databases, and as I'll be sharing a lot about local first approach, you will quickly realize that for us to achieve some of these speeds or some of these standards in ensuring that the user has a better user experience, we can bring the database closer to the user, where the data is stored can come somewhere close to the user or even in users' devices. And once that can be accomplished, things become like very smooth, and it's just a new world for the user. Yeah. So some of the applications which we interact with day to day is like Google Docs, Google Keep. Some of us use Excel, like from Microsoft, or even Google Sheets. They usually feel very fast, and they all in some way use like some local fast approach, whereby they cache your data, and when they cache it, they ensure that it's not every time they need to make that network request or send that whole document from your computer or from your device all the way to their servers, to their server in Google or wherever they are. So some applications that use local fast approach are Figma and Obsidian. Obsidian is a note-taking app which you can work with it offline. Like the first thing you realize with Obsidian is the data lives and stays on your computer or your device. You can have it installed like in multiple devices, and then you can sync in between the notes you took on one device and all of the devices. And if, for example, you make a change in one of the devices, that change will ripple through the other devices, and it's very, very fast. And then you find that apps like Obsidian, you find that they're not talked about like in the mainstream, because in most cases, if the user has the data, there's no need. The money incentives, for example, like the way Google does it, whereby like you have to pay for storage to now keep your own data, your own information. The incentives change, because it's not about making a lot of profit from the user while you are keeping for them their own data. Imagine like paying someone to keep records for you, and then when you can't pay it, now you can't access your records, and it's your records, and they threaten to close your account, and it's your records. So it's usually like we live in a tough world, and we can change that conversation by changing the way software has been, the incentives that software and software companies have pushed along the lines in order to make a lot of profit. So first things first, like what's the difference between local fast and offline? I'd say offline is local fast. Before we had local fast, okay, like when we go back in the 80s or something, I also made this little meme here. When we go back to like in the 80s, the internet wasn't like everywhere. We still had internet, but the kind of internet was not like the World Wide Web. It was just like the local area network, whereby you can just send an email to your boss, and the computers within that local area network can just communicate. And it was a very small community of people, maybe researchers and a few people like in the world had access to it. And so you find that the applications that were built then, they were very resilient. Number one, you could back up your data. You could back it up in a floppy disk or something. I wasn't born then, but I remember seeing those things like somewhere in our house, like floppy disks. And then once your data is in a floppy disk, now you could go to another person's computer and just continue using the same application now with your data there. It was cumbersome because now you had to travel with a lot of luggage, your floppy disks, and then once they get destroyed or something, now you couldn't, you've lost everything. That was then. But it taught us something very important, that users can have like control over everything, even the applications that they use them. So so the things changed when internet became a thing, and now like we had like big tech giants like Google, Amazon, who like now for example with Netflix, now you don't have any movie records. Now if Netflix shuts down, now I can't watch anything. And then if I am offline, I can't watch anything also. And but in a sense, they also gave us some other things such as I can watch it anywhere. I can share it with other people. I can connect different accounts. I can have multiple people watching in the same account. So the advantages soon outweighed the disadvantages. But at the same time, we lost the control of, now I completely own this thing. In the past, when you had a computer, an app was there, you owned the data in that application, which by the way is your data. And then you also own the application itself. You can do whatever you wanted with it, but the conversation is very different right now. Yeah. So in local fast, like introducing local fast to anyone, I'd want them to know like the 7 ideals of local fast stroke offline. Number one is like the idea that there's no loaders or spinners. Like there's no loading state, because everything is within the like is already at the user's table. There's no waiting for that round trip to go, for us to wait like to go fetch the data and now present it to the user. So the issue of loading state is not there, or shouldn't be there, because everything is native and it's already there. The only thing we have to do is to present it to the user. Number two, we will say that your data shouldn't be trapped on a single device. That is where like we need to like sync across different devices. Like the data in one device can sync with another device's data, and this can be accomplished very easily with the local area networks, whereby like if I'm connected to the same Wi-Fi, my computer is connected to the same Wi-Fi as my phone and my television or something, even my fridge. Now they can all communicate using the same network, and they can just share some of the data packets in between like from one device to the other. So if maybe I go to my television and I open the same application, write something on it or delete something on it, it shall reflect all over. And it can be done in a very cost-effective way. Like with the existing technologies already have done it, whereby like you can just localize or you can just communicate in the same network very easily. Number 3 is the story about collaboration or multiplayer, like capability, whereby if we are using the same application and then the same account is linked to maybe my girlfriend or someone close, they can just go and edit it and I can see the changes reflect on my side. And this is regardless of whether they need to be connected to the internet, online or offline. And that is the 4th ideal, whereby like the network should be optional, not mandatory. You can imagine, for example, maybe I've gone to Mount Kilimanjaro and then I still need to open Google Docs, I still need to work. You could imagine if there's no connectivity or something, everything just stops and my world crashes. And yet Google Docs stores my data and that data belongs to me. So they should work to ensure that I can access this application at any time, because it's still my information they have. And the conversation, once the conversation shifts to just being about the user, everything just works very well. And yeah. And some other ideals include security and privacy by default, which means that because I own the data, it's not someone somewhere who shall decide that, okay, we need to open up these records. They also don't have the access, or they don't have full access to open the specific records that are stored in their server or something. And then let me go over the 6th and the 7th one. They can continue to work forever. So like you can remember like playing Need for Speed, and that application was built like maybe in the 90s or 2000s. And if I spin it up, I think it always works. And even if it crashes, there's usually like some backup within the computer, and then it just continues to work. And then the issue of control and ownership, whereby like you can imagine like I have text messages, they are in a single device. I don't want someone to go in and access those specific text messages because it lives on my device. Those records don't need to be sent somewhere and someone else, because of jurisdiction, they decide to open those messages. Yeah. So those approaches, or those things I've talked about, they can be summarized in this table, whereby like we can talk about fast responsiveness, authorization. So when we talk about local, you can imagine that local just talks about before the internet, like before the internet, or apps that are fully offline and they don't have access to like a main server whereby they can sync to other devices and they can cross share the same information to be replicated across them. So this is like an overview of what we've been talking about. And then some of the benefits of local fast, we could just say lo-fi, just to coin like that music genre. So it is the benefits coming in terms of for the user and for the developer. So there's benefits in performance, near zero latency. The latency I've talked about, it's very, very small. It's only computers which can feel that kind of speed. It's not, humans are not perceptible to that kind of latency. And then the control and privacy, and then collaboration, and then most important of all is the offline resilience, whereby like I can just spin it up, work on it, go back online, and then everything just syncs, and I never lose anything. And then the benefits in terms of the developer, or if you're you're an application developer, whether on the front end, mobile, or on the back end, you'll find that the load on the server quickly reduces because there's something I haven't talked about. Like there's something that sits in between now your server and now the client side, or the different client applications, whether be it like a mobile application, like a computer device, or a web application. There's something called a sync engine. So you can imagine a sync engine. It does most of the heavy lifting in terms of maintaining the application state between the user, between the client side and the server application. If changes happen on the server side, these changes shall be brought to the client side in a very meaningful way and in a very fast way. And any changes that happen between the devices of these users, it shall communicate really well in being like there'll be like a reconciliation channel whereby like any changes shall reflect on the other users. Yeah. So just before I talk about like we talk about the technology itself, this technology has already been like it's already been there. So if you're an application developer, like on the front end, you've already interacted with the local storage. But with local storage, the limit is usually 5 megabytes, especially on Chrome. For like the other browsers, I'm not so sure about it, but the limit is very small. And you can quickly, like, the only things you can store there are key value pairs, like maybe a small text or a very, very, very small strings that can be stored and retrieved very fast. And then we have something called IndexedDB, and we rarely use it because it's like an SQL database that sits in the browser. Chrome is especially really good with the IndexedDB because the quota or the limit that your application can save the info, like the storage limit is very large. The limit is usually like, you can check it. Okay, you can check it by using the F12 or inspect, and then you can go to like application and view the IndexedDB quota. So in most cases, I find it ranges between 150 megabytes to almost a gigabyte, but it depends on the quota that is given as your applications run within the computer. It's very, very large. And then for collaboration, the only way we could do collaboration we still use real-time collaboration. It's mostly using WebSockets. And something that can be done, for example, for applications to work offline or to become native, whereby like the user has the application installed in their computers using PWAs. And then you find that with PWAs, it's still a new technology. And then you find that the standards, or like we used to talk about it, but then we haven't done a lot in advancing or advocating for it. So you find that the wheel hasn't turned so much since it came around. Yeah. So there's something else you might ask, like for if a device does some specific changes, and how does that specific change get replicated across different devices? So there's a reconciliation mechanism which are called CRDTs. CRDTs, you can think of them like data structures, but now they store the specific event in terms of the date it took or the timeline it took. These are the specific changes. It diffs into the specific files to look for any particular changes that match, like the original document, and it's like a Git reconciliation mechanism. So with the CRDT, it's a very advanced topic to like really dive into. So I'd advise, like, if you want to know more about it, you can just go to CRDT technologies, and you shall learn like the different. I could say like it's some research level, or like it's some top tier knowledge to really know and understand. And then you find that the technology that revolves around CRDTs is like YJS. YJS is like a collaboration JavaScript library which is built on top of CRDTs, whereby its main job is to make sure like these guys who build like sync engines and databases that do collaborative stuff, they can have like that. They can have like a nice way. They do the CRDTs for them. Yeah, I could say that. And even I'm not so sure like if like Google Docs or like people like Notion, like that, the technology around like Notion, Google Docs, if they really use CRDTs, but I believe they can have their own implementation of these data structures to make sure like the collaboration between documents and file changes between different users is reconciled very fast and very easily. But there's a caveat under this, whereby like sometimes as much as the sync server does a lot of these things, sometimes reconciliation never works. It's like sometimes when you're doing things in Git, you just end up in merge conflicts, and it can't figure out all these diff changes that happened in particular files, different users who did those things. You have to reconcile or do the merge conflicts yourself. Yeah. So in most of these applications like Notion, sometimes it crashes. I'm sure you've worked on intensive stuff on Google Docs, and sometimes it just crashes because the cache is too large. Something on the server, like the original document, now it can't know like what has changed, and you just have to restart the application, and sometimes you might lose data, but it happens like very rarely because the technology around this thing, as I've said, is very advanced, and some very bright people like developed it and made sure that it works and it's very reliable. So the big question is, how do we get started? So there are some things that I've talked about, like sync engines, WebSockets, the client server database. The thing I'd like to say is like we are in the early days of like lo-fi or local fast technologies, and you find that like for most of the solutions that have been built, there is like you'll find that, for example, like Replicache, which was built like maybe it was like in the first people who developed like these sync engines. You find that there's a particular direction they went, and then they realized that we can't fully solve this problem in this particular way, and now they've shifted, and they now have to like rebuild something, the sync engine itself, because the technology is not easy. That's what I'm trying to say. The approach that we've gone with, like the client server approach, has been battle tested a lot. But when it comes to local fast, you find that there's a lot of hiccups along the way in the development, in the advancement of these things. So it's not easy getting started with this technology, and you'll find that, or I'll show you that implementing it in an already existing application, it's very, very hard compared to like starting it from the get-go. And you find that for most applications, they need it later on. So that's why you don't hear a lot about this thing, because it's to really turn this wheel, it's very hard, but it's not impossible. Yeah. So I'd categorize the common solutions that are existent in local fast. first we have like the document and database sync. So that the document and database syncs, you can imagine like Firebase, Supabase, like these backend as a service platforms. You can categorize, you can say that those are document database. I don't know, they like, you can say the way they store information, they store it like in the document, and then they have that architecture whereby like we shall store it as a single document in our database, and then the changes that are affected on this particular document or this data stored as a document, now it shall ripple through all the subscribers, or the subscribers that observe or are looking for these particular changes, they shall get the latest changes. And then you find that for the document syncs, the document syncs rely on the CRDTs, as I had mentioned, people like YJS or the library like YJS. You find that they are the ones who like do the low level things for the users, who, or the people who now develop the sync engines. And now talking about sync engines, what they really do is just like communicate between your database and communicate between like all the instances which are subscribed to receiving the changes that happen between the collaborative devices and the server itself. So most of the technology, or it's like everyone is just on the sync engines. So sync engines, like an example is Electric SQL. So with Electric SQL, you find that what they try to solve is what they try to solve, or how they solve it, is by having like Postgres have like many instances whereby it communicates with the Postgres itself to have like a reactive data exchange. And in having that reactive data exchange, you find that the clients who are subscribed to that particular sync engine, or you can say they are still connected to the server itself, but it happens so fast, and the application state now, which the client relies on, it happens so fast, and this now translates to a local fast experience. So so the demo today I'll be showing will be a very brief demo of how like we can have an electric SQL connected to our Postgres database, and then this electric SQL sync engine communicating with the Postgres database will also be connected to the React application. And now the communication happens so fast, which now gives us a local fast experience. So let me share my screen. So I have like I have this application running. So this is the client side. So let me show it to you. So the solution that I've gone for is using like a TurnStack DB with Electric SQL, and then our database is running on Docker, that is Postgres. So something cool I wanted to show is that I have two instances of this application. So if I can just So you can see like there's this part whereby like I can create like a new to do, and then in adding that particular to do, you can see, so you didn't see like it happening in real time, but if I delete, like, let me just edit it first. If I edit it and save it, you'll see very quickly that it syncs to this other application. So it happens like instantaneously, and I didn't have to go back to this application for it to sync there. So you find that to have such an experience in using local fast, we can get that instant feedback from the client and the server and the different users. You can have like user one here and another user on this side, and now you can take it up a notch higher, whereby you can imagine this like your mobile phone having access to this application, and now you are on this computer. And if I delete like maybe this to do here and another one here, it reflects on all my client applications. So that's a very brief demo. And if you want to take a look at the code itself, you can go to, let me get this link and share it in the chat. So if you want to play around with the application, you can do it. You can just go in the chat and go to the GitHub, clone the application, and also run it. I've put some installation guides on how you can run that application. And then if you have any feedback or you want to contribute to that particular project, you can do so. And that is the end of my presentation. So I invite you guys, if you have any questions, or I know most of the things that I've talked about, it's not the stuff you hear or you'll stumble on it on a day-to-day basis, but it's something interesting, and I hope that the world moves more in this particular direction, whereby we prioritize users, or the conversation is just about the users and not about other ways of making money off the users, because this eliminates profit. It kind of eliminates profit making, but it's more about bringing more value to the world. So if you have any questions, you can just put them in the chat, and thank you.
Thank you so much, Lioba, for the good presentation. Let's welcome another speaker on the stage. Albina, if you're there. You're welcome.
Yeah, I'm here. Thank you. Okay. So, hi guys. My name is Albina. First, Rioba, that was a very good presentation. I've learned a bunch of new things. I didn't know the Tanstack had a database, so that was really cool. I'd also want to first thank React Rwanda for having me. I've been looking forward to having an international talk, and this is my first one. So yeah, I'll get right to it so that because of the time. You're seeing the useEffect screen, yeah? Okay. Okay. So today we're going to be talking about useEffect. I know most of you are familiar with useEffect and what it does, but I'm not going to teach you how to use it. I'm going to be teaching you how not to use it. Okay, how to avoid it, not completely, but yeah, how to avoid it. So I'm gonna start off. My name is Albina Nyawera Muturi. I'm a software engineer from Nairobi, Kenya. Whoop, whoop. When I'm not writing code, I'm also a muscle mommy. I lift heavy weights to relieve stress because of the weather and Nairobi environment. Yeah, and I also like to teach and learn in the industry. So that's a bit about me. And today I'm going to be talking to you about useEffect and what it is. So in the applications that you write, you are aware of like multiple hooks, use states, and useEffect is one of the most effective ones. useEffect is one of the most effective hooks, mostly because it handles side effects. With side effects, I mean something like fetching data from third parties, APIs, or checking maybe the size of your screen and making sure that the visual representation of that is as you expect. For example, changing screen sizes, you can easily use useEffect. Those are the kind of side effects I'm talking about. And the data structure of a useEffect, it takes two arguments. One is a callback function, and the second one is a dependency of arrays. So it looks something like this. It has a function that tells it to do something, and then there's a cleanup function and an array of dependencies depending on the props and the state changes that you expect in your component. So this makes it very, very useful. A little bit of why useEffect is how it is. Or why not to use it, I guess. So it's one of the hooks that had a lot of commotion when it came out, because for those who've written React long enough, you remember the classes we had, the class components that were eventually replaced by hooks. So what would happen? You'd have a function called component did mount that once the component mounts, it keeps track of a certain change. If there are any props or anything changes, there's that component did update. And then once you move from that page, there'd be like a component did unmount. Those are the three major functions that will keep track of what was happening in your function, in your component. So what the React developers did is that they put all these three functions in one, which is the useEffect. So what happens when you run a useEffect is once the component mounts, it first runs the useEffect. The useEffect will check whether there are any changes in props or any state management, and then update your component based on those changes. And then we have this cleanup function, which handles the component will unmount that was previously there. So that's just a bit of history on how useEffect worked and how, sorry, give me a second, just in case I'm missing anything. Okay, yeah. So the problem with handling all this in one function is that it causes visual flickers, mostly because as I've explained before, what happens first is the component mounts, and then the props are updated, and then once they're updated is when you trigger the use effect. So you can notice a little bit of visual flickers with changes in or updates in your state or your components. We've also talked about this dependency array. Let me talk about it a little bit. So what happens is if I have a counter, we'll see that ahead, but if I have a counter and that its state changes or the value of a prop changes, it's going, okay, let me just use an example. Okay, something like this. Let's use this. So I have a counter and I want to check if a counter is doubled. For me to, if for this use effect to be triggered, it depends on that, on this, the state of this count changing. So every time that count will change or this count gets doubled, we're going to have this effect being triggered and you're going to have a complete re-render of your component. Yeah. So the first issue I've highlighted here was dependency health. So as your app grows, these dependencies could become too many for you to handle, and you could have like some stale dependencies, and also you could have dependencies that you don't need, and eventually you'd have like infinite loops, which I'll also talk about later. We also have performance pitfalls. So what happens mostly with use effect once there's a change, or generally with React, once there's a change in components, in props and states, there's usually a complete re-render for your UI. And sometimes, because of the dependencies that you put in your use effect, the re-renders are unnecessary. So yeah, so that is why not to use a use effect. I'm going to show you a bit of the pitfalls that you could fall into while you are working with use effects. The first thing that could happen is you could fail to have a dependency array. I've just briefly talked about the dependency arrays. It just keeps track of what is changing. So when this is just empty like this, it tells the React app you don't need to, or it can call the use effect, but it knows that there are no changes. So this effect isn't triggered to cause re-renders. But the minute that you don't have the dependency array here, it is every time, for example, I have a button that checks the count, this will be triggered. If I have a submit button, it will still be triggered. If I have any event that is completely unrelated to this set count, in this use effect will be triggered. So you'll have, this is what I was talking about, re-renders that are completely unnecessary because you missed something like a dependency array. So yeah, this is actually more common than you think. I've been a victim once or twice when I was young. So the second thing, a second pitfall that you would fall into would be infinite loops. When an infinite loops means this, it doesn't exit. There is no way of exiting this. Till again, same to the other one, but this time it will cause a re-render. So let's also now, this time let's double our count. You have a use state that checks the count, sets the count if there's a change. If it's doubled, we also keep count of that. But in this case, the set doubled, the set doubled in this case is keeping track of the count already. Almost, it's keeping count of it. It's triggered once the count is doubled right here. So this already keeps track of that. So the minute that you add it here as a dependency array, what happens is the component is first rendered, then this effect runs, right? But what the effect is looking for is whether the count will change and whether the set double will change. And the minute this set double changes, it means the effect will run again. So anytime that this count doubles, it does a double. It sets the count to double here, and then also does it here. So yeah, you just got in a loop of that function doubling. It's called repetitively. Yeah. 3, which is going to be the core aspect of this brief talk. The one pitfall that we've been falling for, or if you look at one of your old use effects, is that we usually have our set states within our use effect, which is something we should try and avoid. So that, yeah, if possible, we are going to have this calculated outside or handled in a different way. So once React 18 came out, we had something called strict mode. And what it does is that it runs your effects first. And then first, when it mounts them, and then it unmounts the effect and then remounts them. So if you ever check your log, if you have any console log in your use effect, under most circumstances, you'll find that you have 2 logs. The first one when the component mounts, and the second one when it remounts it. So this is React's way of telling you that you're having an unnecessary use effect, mostly because you've probably set the state and there's multiple triggers, or you have failed to have a cleanup function. So let me talk briefly about the cleanup function. I hope you guys are with me. I don't think people are responding here, but I hope you guys are with me. Okay. So here we have a function, as when I was explaining about the data structure of the use effect, look what it looks like. You tell it to do something, maybe fetch some of your users, fetch the users, and then a cleanup function, say like return true. I can't remember how I used to write those functions before, but yeah, you have a return statement at the bottom that sets your function, your use effect to a default or updated state. Yeah, an updated state. So if you find yourself that you have those 2 triggers, those 2 logs, once you run your effect or you run your component, there's a high likelihood that you haven't cleaned up your function, or there's something with or you've set a duplicated state within your use effect. Yeah, okay. The good thing is React handles this. It already tells you maybe you should consider something else. Yeah. Okay. So I've already shown you why you shouldn't use your use effect. I've also showed you how the pitfalls that you could possibly fall into while writing your use effect. And now I'm going to teach you alternatives. So I built this small code snippets where I'm going to do 2 comparisons of how to avoid using them. As we discussed, what use effect does, it handles side effects. So for example, here I have filtered results and I set the filtered results. using my use set, but my dependency here are the query results and the query and the results if I'm having a search function. And if it's filtered, I just use this function to set the filtered results based on what has been filtered here. Sorry. So with this, it works. It's okay. But you can have an alternative. We can use an alternative instead of having all this amount of code here. We can compute our filtered results without having to use use state. There's a whole other talk about using use state, but also using use state and setting the use state and the use effect. So what we do, we just have this function. You just get the filtered results using the filter method. Yeah, I'm looking for words of how to describe how I got rid of the use effect. I simply just computed the filtered results without having necessarily setting the state, checking when the state changes, and then updating it based on the query and the result dependency on our use effect. So you can just have pure functions that take your dependencies or the changes that you expect as arguments. Here it's just as an argument. So if you can compute, if you can find, say, a count without necessarily triggering a use effect, do it. Second, this is something that I found out that was very interesting. When you write, maybe if you're fetching a list of items, sometimes React always gives you this red line that, use a key like to identify what you want to check. Like for example, if I'm getting a list of users, I'm going to use the ID. So here is just the same thing, but here I want to teach you how to use the key to be the one that's triggering a re-render instead of having a use effect. So when you have a use effect, this one is just a simple example. We have a counter. When you click a button, it sets the counter. It adds +1. Yeah, and this one is based on the game ID. So we're checking if the game ID changes. Then the count associated with that game ID should also change. Yeah, very simple component. But now I'm going to show you how not to use it. So what we're going to do here is just use this counter function to just register the state of the count. So here, to register the state of the count. And then we have a game function here that is going to keep track of the game ID and when it changes. So in this case, we pass the game ID as the key for our counter component, such that instead of triggering a whole use effect and its re-renders, well, this will also re-render, but it gives this counter a unique identifier for that game ID. So the instant that that game ID changes, the counter will also update based on the game ID. Yeah. So if you can use the key identifier to check when the prop changes instead of relying on the prop changing on the dependency changing, that will also be a better alternative. Third, which is very useful, is using custom hooks. I think some of us have gotten into the pit of this. I remember I used to write my local storage like this. I always said I use effects that will handle getting values from my local storage. Again, this one has a lot of key issues that we've highlighted, like setting values within your use effect, setting values within your use effect. Yeah. So instead of having a function like this, you can just have, I think this does the same thing as what we've, no, not really. So here, just have a pure function, not a pure function, just have a function that does what you want it to do without having to pass dependencies. Yeah. So in some cases, the changes that you're making really don't need an update with dependencies. They just, yeah, they don't need updates with their dependencies. You could actually just have custom functions that do what you expect them to do. Yeah, I think that's it. And for my last alternative is using third-party dependencies. This is one of my favorite things, or just finding libraries that do your heavy lifting. So here it's an alternative. It's a good alternative in as much as other libraries will have useEffect working under the hood. They just do a lot more heavy lifting. One of the libraries I'd like to talk about is Tanstack Query. Tanstack Query. Yeah. So I think most of you have come across Tanstack Query and the amount of work that they're doing. So with handling your data fetching, it also uses useEffect in the background, but it does a lot more. If you're building a small application, it's not necessary to have like a whole Tanstack query going with your fetching, but if you have a growing or scaling product, it helps you handle your caching. It helps you with things like memoization. It helps you with pagination, and it comes in just like a single line of what we used to do before in like 6-7 lines or more lines. What we used to do before was like set a loader to through even fetching data, then have a function that fetches the data, and then handle our errors in between. And then once we've run through that promise, the next thing that we do was set the loader to false, right? That's how a normal like useEffect for fetching data from an API would look like. But what third-party libraries like Tanstack Query will do, they have a use query hook that comes with an object. It has the data that I'm fetching. If I'm fetching a list of users, I'll just have it set to users. And the loading, if I'm fetching data, it just already has the isLoading property set. If I have an error, I have an isError. I have an error property here. And then this use query hook checks what I'm fetching. If it's the user, if I'm checking it based on the user ID, and then just fetch the users. That's literally it. Before we do this in so many lines, and then we'd have to focus on things like checking, have I cached my data? Is my data stale? Things like that. But with this third party library, in as much as it uses useEffect in the background, it gives you a lot more capabilities with very few lines of code, as we've seen here. Yes, I think I've kept time. I've made it short and brief so that it could save on time. So You can ask me some questions, please. Oh, sorry about that. Anyone with questions? Yes, derived state can fetch your values from the states which is kept which you track based on your props. So if the props change, the state change, yeah, and you can always derive that from your props. Okay, if there are no questions, asante sana React Rwanda for having me. This has been a pleasure. Thank you.
Thank you so much, Albina. We're going into the Q&A session where we're going to welcome some questions people wrote in the chat. There is this question I saw earlier when Josue was representing. If he's still there, may come and answer it. Josue, Mr. Josue, can you hear me?
Yeah.
Okay, that's great. There's this question someone asked.
Oh yeah. Yeah. Udusha. I don't know the name. Yeah. Basically, is you have some. It's not like something like lines about like credits, but you can pay if you don't have. If they don't want to pay, you have like some credits to perform in the AI. Um, yeah, for some AIs, you can just clone it and then learn it from your local machine. But if you cannot afford to run it in your local machine because it takes power and also it needs more powerful devices, you can just pay or just use credits. I've been using V0, but I haven't like got it to the time to pay, so it's very enough for me. Yeah, but yeah, if you feel like you need to pay, yeah, you can pay, but you have like credits that you can perform almost like every day, except if you want like to make crazy things with it. But if you want like something to help you, yeah, you can do that. Yeah. I think that's how I think that's my response to that. Yeah. I hope I answered it very well. Yeah.
Yeah, okay, thank you very much. I think there are no other questions people wrote in the chat, but if there is any speaker who may want to add anything else, you're welcome. Is there anyone else who want to add anything else? So we really appreciate, thank everyone who joined us today and those who will be watching later. And shout out to our great speakers. You really made this happen. We really appreciate your time. You taught us great things. I think we have learned a lot and we're looking forward to have you on other sessions. Thank you very much. I personally would say that I've learned a lot. As someone who is trying to specialize in as a front-end developer, I've learned a lot from you guys. Thank you very much. And the other thing I will talk about is our next events. So please keep following on our different social medias. We have a lot to give you, so keep engaging. We have a lot to give you, to offer you as our community members. Another thing I would say is, if you want to assist or contribute to the community, to the React JS Rwanda, you're very welcome. You may reach out to anyone if you have something to give, to educate on. So you are welcome a lot. And I want to give big thanks to the team members who made this happen. They did a lot of work organizing the event. As you can see, everything went on well, and we are really glad that we had the things went on smoothly. We do appreciate you guys. I can see Mr. Rioba. Do you have something to add? Because people here were amazed by your presentation. Have a lot of in the comments. You have a lot of people thanking you for the good presentation. If there's something you would add, that would be great.
Thank you. Thank you for bringing the mic back. There's something, maybe something I'd add is that local first. There's another realm of advancements that are happening in the TCP, like in the internet protocol, that layer whereby like internet packets are transmitted between a server and the client. So that is to ensure that there's no that two-way bidirectional transfer, and whereby like you have to have like, you know, the way the internet works, or like a connection is made between the server and the client. There needs to be an acknowledgement between like the server and the client itself, and then another acknowledgement that now I've received, like the server says that I've received that connection and it's established. So it usually takes, in terms of human perception, it doesn't take like a lot of time, but it's a round trip and then another round trip, and then like the connection is established. So Vitalik Buterin, like the guy who developed Ethereum, they are working on another protocol, like, which isn't TCP anymore, whereby we don't have to have that like many round trips, and a connection can be established in a way that is faster, and it improves on the existing implementation that we have. Yeah, so that's one area. Let me get a link about that particular technology, and I'll link it in the chat as well. Sorry, back to you.
Okay. Leo, but you're sharing the link in the YouTube chat.
Oh yes, yes. I'm still trying to get it, but we can continue. In the meantime, I'll just link it in the chat.
Okay, that's fine.
Yeah, thank you so much.
Yeah, thank you so much. I want thanking our great speakers, Mr. Eugenie, Mr. Josue, Mr. Ryoba, Miss Arbina. You really gave us great presentations. Thank you so much, and we're looking forward to welcome you in other events and sessions. Thank you so much. I also thank a lot our team. Mr. Didas really had contributed a lot for this event to happen. Maurice, Nancy, Miss Nancy, Queen Bella, thanks so much. You've been promoting the event and everything really went on well. Thank you so much, Miss Giselle and Miss Erin. So my final words is that keep on following, reacting, like engaging in the communities for us on LinkedIn, on WhatsApp. Make sure you join the community on Discord. So as we end our event, I want to thank everyone who has watched from the start to the end. It has been for a long time, like it is about 3 hours, but we thank you so much for joining and for your time. We thank you a lot. So good night everyone. Thank you so much.